I invite now Yen to launch the first workshop on the Copernicus Data Access Service. Thank you very much.
Okay, thank you very much. So maybe I will ask all colleagues to already join us here at the chairs. So today we will be talking about the Copernicus Data Space Ecosystem. But maybe before I begin, first of all, I would like to thank very much to ERGS for having us here. And second of all, I would like also to thank Elizabeth because she has already provided us such a nice introduction to CDSE. So my work is really easier now, and we have more time for questions. So regarding the questions, I have one for you. Who has already registered to the CDSE platform, which is operational since January? I cannot, yeah, just one, two, but you are from consortium, so you don't count. Okay, so hopefully after this, our presentation, our workshop, all of you will sign up for the platform to see also the capabilities that it brings. So let me start with the agenda for today. With the clicker, if it works. It works. Okay, so I will give you a short introduction into the Copernicus Data Space Ecosystem, and then Yuri Delamar will tell about the vision of the project. Then we will have a short introduction to the Open EO API given by the Denis Claris from Vito. And then we will see the use case of the Copernicus Data Space Ecosystem in the framework of the Common Agriculture Policy given by Andras Zelinski from Synergize. So to start with, I will tell you a little bit what revolution does the Copernicus Data Space Ecosystem bring in terms of data access, data discovery, visualization, and processing. So maybe I will skip this slide already because it was told about the Copernicus program with the Sentinels. And you have to also keep in mind that this is not only about the satellite data, but this is also about the in situ data, which are fed into the system in order to produce the added value products, which are generated by the Copernicus services, thematic for climate, for marine, atmosphere, land monitoring, security, and emergency management. And how up to date you will, there was a possibility to access the Sentinel data. This was of course through the Copernicus Open Access Hub. This where you could reach the Sentinel 1, 2, and 3 data. For Sentinel 5P, there was another data hub. For the Sentinel 6, the data were distributed by EUMETSAT. So you can see that there are many data hubs to access just one Copernicus collection of all satellites. And what was also important now that the data after some times were rolled to so-called long-term archive, so LTA. It depends on the product and the region. It was from months to years that the products were not anymore immediately available. You have to restore it from the long-term archive, and this could last from hours to days. And this was a big problem for people who would like to process a long time series of data. And this could be a little bit overcome by the access to data via the Copernicus Data and Information Access Services, so-called DIASs, where the data were on some DIASs provided the full archive of Sentinel data. And using this and the processing power that were available on the DIASs, users could generate added value products and have their own services running. So there were 5 DIASes, namely CREODIAS, Soblo, Vikio, Onda, and Mundi. Since January this year, Soblo is not working anymore, so there are 4 DIASes still in the game. And to start with, the CREODIAS laid the foundation for the Copernicus Data Space Ecosystem with its 35 petabytes EO data repository, and with the computing power which is now distributed through a few cloud environments. The CREODIAS cloud is based on open source solely, with OpenStack for virtual machine orchestration, and with Ceph storage with the Ceph for storage. And it has other features. For example, for scalability, you have Kubernetes with Docker, where you can deploy your microservices. You have on-demand processing in case you want to generate higher level products, for example, Sentinel-1, Coherence, or Backscatter. And it's also free for testing, so we provide 150 euro credits for testing. So another important component that laid a foundation for the Copernicus Data Space Ecosystem was the Sentinel Hub, with its Sentinel Hub browser, and with wide portfolio of APIs that allowed users to develop their own services. So to summarize the Copernicus program, I would like to show this BIS graph. I will not go into the details, of course, but I think it very nicely reflects the complexity of the Earth observation monitoring, with the European Commission as a program manager, with the space component managed mainly by the ESA and EUMETSAT, with Copernicus services managed by the wide range of agencies, starting from ECMWF, EEA, also there is a Mercator space, and many more. And all of these services provides a lot of data. Yesterday somebody said that that we are floating in the sea of data. I think we have already drowned in this sea of data. And for this, you need the Copernicus Space Data Ecosystem to manage all of what is floating or what has already drowned in this data pool. Maybe I will also skip a bit about the introduction, because it was already given by Elizabeth. So I will tell more about the revolution that it brings. So first of all, it's collaboration of experts across Europe. I know that maybe this sounds a little bit pathetic, but still I think the cooperation in such a large project it's a key, because otherwise it wouldn't be possible. So we have test systems as a leader from Germany, we have Cloudflare from Poland, Synergize from Slovenia, Vito from Belgium, DLR from Germany, Acri from France, and RIA as well from Belgium. And the second revolution is related to the immediate access to the data. So this is what I was telling you about, that currently the data are rolled into the long-term archive after some time, but not anymore. Now you have immediate access to all Sentinel 1, 2, and 3, 5 data. But not only, there are some added value products already generated, such as, for example, level 3 temporal composites, quarterly, monthly, and yearly. There are some also on-demand processing. This is what I have already mentioned in a best effort mode. So this is for free, provided to users. So in case you want to generate a backscatter or coherence, you can order this products. We will put it in the queue, and as fast as the queue processes, your products will be generated. Unless you go for the commercial offer, then the you can provide a large batch of files and it will be computed quickly. And we have also Landsat imagery over Europe originating from ESA archive, but now we will also download the rest of the world, the new collection of Landsat data, but this probably will take a while. We have the soil moisture and ocean salinity mission. We have JSON-free altimetry. We have archival data of Envisat MERIS and ASAR. And we have selected products from the Copernicus services. Why selected? You may ask, because basically we also do not want to replicate what is already there. Our approach is rather to federate than duplicate the archives of data. And more products will appear soon as long as along the execution of the project. And another important component are the Copernicus Contributing Missions, which were also mentioned already by Elizabeth. So these are the other ESA missions. They are the member state missions and third-party missions that were used to complement the Sentinel's imagery. They are mainly composed of very high-resolution imagery from Airbus, for example, Pleiades or Spot. World view, there were some also radar data, such as Cosmos SkyMet, RadarSat-2. So these data will be also available through the Copernicus Data Space Ecosystem. In case a user wants to order VHR imagery that is not within the CCMs, it is also possible to order, to place a commercial order through the API on the help desk, and you can see that we have here a wide portfolio of providers. So for sure there will be some solutions that will fit your needs. This is another revolution that is that was already mentioned by Elizabeth regarding the traceability of the data sets. And I think that this is really important now, especially yesterday we could see from Giovanni that he displayed very nice satellite images that were produced by AI. So now we are not anymore sure what we are dealing with. And with the traceability API, it will be able to trace the generation, the whole life cycle of the EO product. Through the checksums, you will be able to say what was the origin, which files were used to generate this product, and what was the computing center, for example, that generated this product. So the digital signatures will allow you to verify the authenticity. So then it shouldn't, you should be able to yourself to discover if the image was provided by AI or not. The API is already running, so you can check it here under this link. Another revolution is with the advanced data discovery and visualization. So here we are talking about the Copernicus Data Space Ecosystem browser. To date, the browsing capabilities were limited with the data hubs, but now it has changed significantly. This is already the feature that is running. So you are able to, first of all, to search for the data, but also to visualize it in a non-standard way. So you can create your own false color composites, for example. You can also generate such nice time-lapse images to see how the process evolved, for example. So here we can see the snow cover, and you can also visualize it in the 3D. And what is more also important, that is you can do using only your web browser. So this is not anymore, you don't need any specific software for this. It all runs in the browser. You can also download the data, and here you can download a subset of data. You can download this false color composite, for example, that you have created. You can compute NDVI, simple band math, and download the results. And for this, we also provide advanced data access and processing APIs. So for data discovery and catalog, we have Stack catalog, we have OData and OpenSearch interfaces that allow you to locate the products that are fulfilling your query. You can download products directly using the S3 interface with the keys that are generated for each users. Or you can download it through the OData API. You can stream the data, so using the Sentinel Hub and OpenEO API. So this is possible using the Stack catalog. The visualization is also possible using the OGC services, such as WMS, for example. You can process data and compute some statistics using instant, so for single imagery, and you get the result instantly, or you can place a batch order that will process the data after some time for a larger volume of data. And you can also bring your own data for in the cloud optimized format. So here it's TOG or ZAR. We have also software development kits such as Python and JavaScript, and client for it written in JavaScript, Python, and R. So when you face a problem, first of all, you can go to the documentation, which is already available to see how you can use the APIs with some examples, like here for NDVI. You can also contact us through the service desks. We have a user forum when you can post your questions. You have a web forum and email support, and video tutorials with some code snippets. So here I would like also to make some distinction between there is a public offering that it's completely for free for users with some quotas based on the user type, and this is what ESA and Commission grants to a user, if it's a regular user or is it a kind of a super user. You can onboard your services also, and for this there is you can do this from the through the help desk to say which services if you would like to add your services to the Copernicus Data Space Ecosystem. And they are commercial offerings by third parties, so they are the payable services, and this is currently the CREODIAS platform, which also allows you to self-onboard on this, and here you get then access to large computing capabilities in case you would like to process a lot of data, or if you would like to establish your service, for example, on the cloud. So this infrastructure as a service, so virtual machines are provided now by Cloudflare and OTC. There are many virtual machines, small, large, depending on the flavor and the workload that you would like to achieve. There are some GPU acceleration as well, so this is good for AI and modeling. You have then object storage with S3 interface. You have flexible billing modes, so you can pay as you go. So this kind of a credit system when you charge your account, and then as long as you compute, the credits are cut down, and this allows you also to control how much resources you spend. There is also a possibility for long-time contracts, for so-called fixed contracts with some discounts, and we have also discounts for scientific users, and we have also 24/7 support in case you run into some problems. So regarding also the commercial offering, I would like to mention that there are already some options to get funding. One of it is through the network of resources established by ESA. So here you just fill a form. It takes 15 minutes. I have already done this. And you can be granted 5,000 euro credits if you are not ESA project. And if you are ESA project, you should contact your project manager from the ESA side. And then the limit is the amount that ESA allows you. And the second options, for example, for the research environments, it's OCRE project, Open Cloud for Research Environments, when you can also get an access to Cloudflare and the system clouds. So to summarize, what I would like you to remember from this short introduction is that the Copernicus Data Space Ecosystem grants free and immediate access to EO data. It's not only from the Copernicus, but also, for example, from Landsat missions. Then the ecosystem will replace the current Copernicus open data hubs in the fourth quarter of this year. Along with the data and ecosystems, ecosystem offers powerful data discovery, visualization, and processing tools and APIs. And this is the revolution that was not available to users before for free. Free public offering is complemented by commercial ones. So here we talk about the cloud computing, virtual machines, and very high resolution imagery. Also, ecosystem is open for any entity that would like to federate. And as it was already mentioned, we provide long-term perspective for fruitful cooperation. So the project is aimed to last 6 to 10 years. So this will ensure smooth development of the functionalities. And as to conclude, I would like to also to mention or to emphasize that this is the joint European effort. So please, if you have service that you would like to think that should appear in the Copernicus Data Space Ecosystem, contact us and we will try to deploy it on the platform. So that's it from me now, and I will hand over to Yuri de la Mar, who will say a few words about the vision of the Copernicus Data Space Ecosystem. Okay, thank you.
Okay, thank you, Jan, for a great introduction. Of course, it's, as you've seen, a huge project with a lot of data and a lot of services. So might be that you ask yourself now, oh, what's in it for me? How would I be able to use that? But I believe in this room especially, I believe a lot of you are working with Sentinel data. So for me, it would be interesting also to know, maybe as a first question, who of you is really creating value or business on top of Sentinel data? Could I see some hands? Right, very good. So that's, I think, why it's so important for us to be here with you, to interact with you, because I think that is exactly what we want to do in Europe, with the help of the Commission and ESA support to even more enable this business, create new opportunities. And I hope with the few slides that I will share with you, that I can give you some idea of how we want to accelerate that over the next years with the data space. So we go to the next, So in terms of the relevance for you and for everybody else in Europe, what we see is that with this we can not only continue with what we have done in the past maybe. I think a lot of the services that we see today have been characterized by creating maps, creating products, and then do that on a regular basis to help the user community understand what is happening in climate change, in environmental issues, in other societal relevant issues and also, of course, to help industries to manage their business better. What we believe the next step, and I also call that really a paradigm shift, is that on top of that, we should try to make people able to ask questions and not to figure out what questions they might have, but simply turn it around and say, instead of us thinking of what the next question should be, let the user ask that question, or let the service provider, you, ask that question to the data space. So ask Copernicus, I would say. And that, of course, we have seen also from yesterday's presentation from ESA that we see that all, say, complex data problems and data repositories are trying to enable this going forward with a whole range of new tools. And that's exactly what we want to foster as well. So that requires, of course, a whole new range of apps and services. So I think the other main difference with the existing services, data access services that have been provided so far, I think the more important part will come after my presentation, where we will exactly address this. How can we enable you as service providers and the user community to ask such questions with new tools and make it very simple to do that? Also, maybe keeping the questions you have asked and be able to repeat them once and again. So I think the next presentation with Dennis, going into the OpenEO world, that will give you a very good idea of what it means and what it can be for you as a tool. And that we can also do with very low incremental cost. I think one of the things, of course, in Europe is to be very efficient, to be competitive in a global world. We are in a global world, and we want to create you also as champions of this. So to be very efficient in this data processing, creating information, creating intelligence, will require to do that very efficient. So you will see that a lot of the services and a lot of the data, actually almost all of the data, is free. You don't even have to store it yourself. But it also gives you the chance to add your own services and your own data in a very efficient and low-cost way, to combine it with the Sentinel data, with making use of the cloud resources. So, as a summary, I would say the data space is not something that we provide for ourselves or on behalf of the Commission. The data space is really also for you, for service providers, for end users, to participate, to promote what the European community has in terms of services, what they can provide with new data sets, with new services, and to be able to control that with the things that we will implement, for example, to have a very fair and transparent membership governance of the data space. So if you become a member, you will exactly get the same rights, the same access, the same roles as we that have started this. And your service will be presented exactly the same way as any other service. So it will be a level playing field for everybody, and each user will be able to find very quickly what is available in the ecosystem, not only our services, but also your services. And with that, we also have, of course, a responsibility. We are driving a European project, so we want to be compliant with things as the European Data Strategy that is formulating also how to govern the data with the Data Governance Act, the data itself, how to manage that with the Data Act, the Cloud Act. So all these things, you can be assured that we will implement this, and you as a service provider will not have to deal with this complexity for your particular service. All these things will be built into the membership rules, and also the way how you can use then the system to work for you. And that, of course, is sometimes new, I think. Have anybody of you worked with federating your service with another service? Federation, I see some hands. This is where it might get new and innovative, because to do this efficiently in the IT world, we know you don't want to log into 15 systems and remember 25 passwords. We want to make this as efficient as possible with these new federation technologies. So if you are running a service with your user community, that they can actually use the data space without having a new password, without having to remember access codes, but simply by this federation enable them to use the service and also have a machine able to use the service through machine-to-machine communication in a very secure way. And also in the future to have the capability to even search amongst different services. For example, for data, not only data that is in the Sentinel repository, but data across other repositories, other data spaces maybe even, like the Green Deal data space you will maybe hear about later. So this will be also for us one of the key drivers to enable it for users to really see and discover what they can use in future. So let me summarize. For us, going forward, this dialogue with you, with others in Europe will be extremely important to learn and to understand from you how we can make the service as attractive as possible, how we can continuously extend the service, so it's not about just now a one-time implementation. We have a very long 6 to 10 year horizon. We want to use that and create again and again new opportunities, and to promote the European community. Again, you, other service providers, startups, researchers, to participate in this ecosystem and to create out of that the new global champions working with Copernicus data. And for that we have, of course, a roadmap. We cannot do everything at the same time, but we are already well advanced, as you have heard, so I will skip this quickly. We are now approaching the 1st of July, where I would say 90 to 95% of all the data and services will be available for you, also then to switch from the current data hubs to the Copernicus Data Space and start using it, start experimenting with it, and then we will be adding new services along the way, and also listening to you to maybe get new ideas. What should we add or what should we combine in the future going forward? But let's now have a look at one of these very new services that will hopefully make your and our life easier. Let's go to Dennis with OpenEO.
Thank you, Jerry, for the introduction on OpenEO. Indeed, OpenEO is relatively new. Who has heard of worked with OpenEO in the past? A few hands, okay, good, but we still have some evangelization to do, I think. So let me dive into that directly. I think we can start with a little bit of history here. Sorry. The green one, yeah. Yeah, so OpenEO, why do we think it's a game changer within the Copernicus Data Space Ecosystem? We already worked with OpenEO for quite some time. So actually, OpenEO is a project that was funded by Horizon 2020, starting in 2017 already, where a lot of bright heads in Europe came together to work on this new novel API, actually, to serve the users with a local to continental scale Earth observation data analytics solution, allowing simplification and unification. So at that time, you probably know that there were many DIASes, many platforms, many companies that had their own platforms. That still is a little bit the case, but you all had different ways to access this data, and it's for a research perspective or from a user perspective, it's not easy to see the forest or the trees within the forest, let's say. So that was, let's say, the goal of OpenEO, to make that a little bit more unified, a more simplified way to interact with all the data and to reduce the complexity of handling the data. So what we wanted to do, so the goals were to run the workflows for a user work locally in a browser, notebooks, or RStudio, for example, connect easily to cloud platforms in a technology agnostic way, and carry out discovery, composition, and distributed processing without having the hassle of spinning up virtual machines, taking care of networking, security, and so on. So that was very important for us. And then afterwards, of course, show these results, download the results, images, time series, and so on, but also allowing users to have their own custom code to insert it in there, not only some predefined algorithms, but also to have the users build their own script, which are called user-defined functions within OpenEO. And of course, it's open. That says it all. I think there are a lot of community contributions within OpenEO, so we're very happy that that is a thriving ecosystem at the moment. So at that point, you see there were quite some players in Europe that were united. You see quite some of them here. These were part of the original OpenEO project. And we thought, okay, this would be good to put it on top of the new data access system. So that is becoming the case from the 1st of July, as Jury said. We're building up to the final phase before release there, so we're very happy that we can do that. And I will share some use cases and the means how to interact with OpenEO, just to give some practical examples. There is another OpenEO platform project also. It's ESA funded, so ESA recognized the potential of OpenEO, and they're pushing it forward in their digital innovation tracks and so on. So the current ecosystem, the community, is still being fed through ESA within the OpenEO platform. So it's still evolving, which is a good thing, which is driving the community as well. Then complementary to what Jury said, so we want to enable the community, not only for users, but also for data providers, for algorithm providers. And therefore, there is a concept within OpenEO called a federation, OpenEO Federation. And what is that? So the OpenEO is based on process graphs. So that means that people can put together a whole workflow with building blocks, with parts of code. But this concept of a federation would allow these process graphs to be run on different backends. So not only on the Copernicus Data Space Ecosystems. Let's say that, for example, you need Sentinel-2 data, and it's not fast enough, or the resources are depleted within the ecosystem, which is probably not the case for a long time. But this OpenEO Federation would allow that processing is split up for users without them having to worry about it and being deferred to another backend. So that, for example, a national ground segment or another companies, which is OpenEO enabled, can run chunks of the processing distributed. So that's one of the novelties, I think, within OpenEO. Another thing is if you need different data sets, for example, let's say that one is not available within the ecosystem, that this can be split up between different backends. So this will all be happening automatically in the backend, I would say, with this federation concept. So this is a concept that we will enable within the Copernicus Data Space Ecosystem. So you can see there a little bit in the picture on the left, the different colors mean that there are different data sets coming from different providers. So that's a little bit the idea how we would like to move forward with this federation concept, which is very interesting in my opinion. Then leaving the history behind, let's say, going into the Copernicus Data Space Ecosystem, from the 1st of July, OpenEO will offer the standard or the access to the standard Sentinel datasets, so Sentinel 1, 2, 3, and 5P. And then we will add some additional datasets from November onwards and have this federation concept in place from November. And the first backend that will be federated in there is Terrascope, which is the Belgian collaborative ground segment, which also I'm representing. but we have, I think, quite some unique data sets also that can be federated into the Copernicus Data Space Ecosystem. Then looking into the tools, the capabilities of OpenEO, so how can you interact with that is, of course, the Jupyter Notebook. So this is also a capability that will be there from July 1st. What you see now is what we have in staging, where you can, or where data scientists or researchers can interact with the API for interactive prototyping, visualization, programming, and so on. And it's quite a convenient way of quite some users to interact with the data and with the OpenEO capabilities. The second one is, let's say, a low-code environment, which is called the OpenEO Web Editor, where you can simply slide building blocks of your workflow. We even have a wizard on board, which guides you through the process. Okay, I want to have Sentinel-2 data. I want to make an NDVI out of it, and then the code gets written in the backend. So you can see a visual representation of that, and then you can just press play, and that will get executed in the backend for the region of interest that you have selected, and so on. So it's a very convenient way to get results very quickly for people that are not too experienced in coding and so on. They can monitor the results and download the results from this interface very quickly. And visualize them as well. This is one example of a land cover map that was made based on the capabilities within OpenEO. Then last one, I think it's also an important one and maybe a little bit underrated is what we call a marketplace, which we will have, which is actually a place for users, for companies to share their knowledge, to give them visibility on the processes that they make, so they can, on OpenEO that is. There you can easily see what will that specific algorithm bring, how much will it cost for me to execute it, and on costing side, every user will get free credits all the time. They will get replenished on a monthly basis, so people can keep on experimenting. It's only when you need more processing, if you want to have continental processing, of course, that consumes lots of resources, that there is some credit top-up needed, which we can also arrange with the network of resources, as Jan mentioned. So there will be different mechanisms to work with that with the marketplace. So this is interesting for users to have or to reproduce results on different areas, let's say, but also for service providers. So service providers can onboard here as well their knowledge and get some return from that. So they can define their added value. And if these processes are mature enough, or if they are used enough, then you would get a return on this added value. So that's interesting as well, I think, for users. So let's say it's kind of an app store, but then for the Earth observation algorithms. We will govern this, of course, and we will have an assessment on the maturity of the algorithms. We will see if there are peer-reviewed articles on that or papers on that. If there are automatic testing, if it's maintained enough and so on. So we will give a label to each of the service, going from prototype to fully validated service, and based on this ranking, I would say you or users or service providers would be able to get a return. This is a small movie on the capabilities, so a short demo. This is on the on these capabilities on the Jupyter notebooks. On the Jupyter notebooks, we will give a lot of sample code for users to start off with. We will make video tutorials, snackable content that users can easily start with making code, with providing code, but that's not only on the notebooks, but also on the web editor and so on, and on the marketplace. So this is an example of that. This is specifically for burn scar, a burn scar algorithm that was made, and you can immediately show your results here. this is a very simple example of the OpenEO web editor that is currently in staging, where you can, with the wizard, move through the process, select some parameters, and then the process graph is built in the backend. So that will be shown in a second. So here you see all the calculations, the process graph for an NDVI is built. There you can see it, and I think in a second it will show the code as well, which can then be exported, saved. It can be ported into a notebook if you want to do further tweaking and so on. And also you can execute the code there, download the results. So the lower part is really to look at the processing. So there's batch processing, there's synchronous processing. And this is the algorithm marketplace. So this is not really the final branding, I would say, but this is, for example, a service anomaly detection based on OpenEO with some sample code, with some explanation on what the algorithm does. And you can really use it as a building block. So if you need that somewhere in your process, you can easily take that out and put it in your workflows on all the data that is there in OpenEO. So this is a wizard showing that. So I think that's a little bit the demo. I'm not going to leave it running for the time. And then I think one last use case I would say is and now I'm taking my hat off as Copernicus Data Space member, more sitting on my research cap as a veto researcher. We've made this European crop map with OpenEO, and it's we tried it on the data space infrastructure on CREODIAS in the backend, and we needed a lot of data sets. So we did it on the EU's 27 countries. So we needed level 2A data from Sentinel to Sentinel-1 GRD data. We did on-the-fly backscatter. We used also the digital elevation model of Copernicus on 30 meters. So we could easily build that process graph on a continental scale and push it to batch processing. Of course, the European scale map takes some time to process, but you can follow that up in your process graph, and for example, in the web editor. And for our researchers, it's very important that they can easily make prototypes, test it, make new machine learning algorithms or models, put it in there, experiment with that, to come to, let's say, they usually start off with 10% of a map like this, and to see the results, validate the results on a small scale, and if they're happy with the result, they can scale it up. And then this would be one of the building blocks that can be reused in the future. So it's not buried with the result of a project somewhere, but this, for example, would be a nice case to onboard into a marketplace and build further upon. I think other users can use it. They can tweak it towards their regional interests or specifications from a country, but it really is a game changer for our researchers to work in this kind of workflow. So this is really what we are trying to standardize on, and it's really interesting now that we have the global archives available for all the Sentinel satellites, while that wasn't the case in the past. And also from a resource perspective, if you want to generate a map like this, you don't want to worry about setting up VMs, networking, security, logins. So this is really from our point of view, the way forward. So concluding on OpenEO, so we think it's an advanced and efficient handling of the EO data that is there. We can onboard user-defined algorithms. There are many ways to interact with it. So the web editor, Jupyter Lab, so going from prototyping to full continental scale processing. Of course, the algorithm marketplace gives a forum for other users to onboard, not only for algorithms, but also for data providers to onboard through the federation concept. So that's important. I think, with OpenEO, we enable a reference gateway also to the golden EO standard and the federated data sets that are out there in Europe. We're sure of that. I think there are many national collaborative ground segments, many other platforms that would benefit onboarding here through OpenEO. So I think I can conclude here.
Thank you, Jan. We've talked a lot about how cool this system is, how new it is, and what it can do. But I would like to give you a case study, an example to illustrate, to make it a little bit easier to grasp how much of a difference this makes. And first of all, I have to ask, how many of you work specifically in CAP monitoring? CAP, Common Agricultural Policy? Yeah, 3 to 4 people. How many work in agriculture? A bit more. Okay, so to decide whether this is transformative or not, we have to define what we expect as transformative. And I found a really nice definition on this. Digital transformation, if it's done right, is really like a caterpillar turning into a butterfly. So it opens up completely new directions of movement, completely new things that you can do. If it's done wrong, then it's a very fast caterpillar. So what I want to convince you on is that Copernicus Data Space Ecosystem is not a faster caterpillar, it's a butterfly. And the reason why I selected CAP as an example is I think it's one of the largest operational applications of Sentinel data actually out there. So it's carried out at national scale across the whole EU. It's repeated every year, but some of the checks are done several times a year. It involves time series analysis, it involves multiple criteria, and the whole thing has to be legally compliant and financially binding. So, so this is really a big application crunching a massive amount of data. And Copernicus Data Space Ecosystem is going to transform this in a completely new way. This was, of course, part of the vision of the data space. I mean, back a couple of years ago, you would try and find the single satellite image that's collected at the right time and look at it. And now what we do is we collect a lot more images than anybody actually looks at. So the images go into some sort of data analysis algorithm, and the algorithm gives you the result. And we wanted to build a service that is actually an optimal platform for both approaches, the old one and the new one. A little bit of context on CAP monitoring. So this is one of the largest components of the EU budget, actually. The Commission is paying money to the farmers to comply to certain regulations. This is partly about the farmers' livelihoods, partly about conserving landscapes and producing high-quality food. But what it actually means in terms of monitoring is that you have a multi-indicator system. For every single parcel, you want to look at the shape of the parcel, whether it's correct as the farmer claimed it. You want to look at the cultivation practices. You want to look at the presence of ineligible areas that are not farmed, and of course the type of crop. And back before the era of satellite monitoring, this was done by field checking 5% of the plots, more or less at random. So when satellite imagery came in as a solution to this, and all of the parcels were checked in a way, that was already a game changer. So what do paying agencies want in this context? Well, they want a very reliable system that's super accurate and that runs really, really fast, because in the end they have to pay money based on this service. They want every processing step to be traceable, because sometimes there's disputes with the farmer, of course. You have to be able to share the imagery to the farmer, because they will want to look at it, and there's also, of course, a team of operators looking at the specific cases and interpreting the images. And it should be ready for new functionality that can be added on top of the existing code. And this may sometimes be like a big change, going from parcels to pixels, for example. So this is the typical approach. This is a recently published study on CAP monitoring in Hungary. You have the farmer claims coming in, you have the Sentinel-2 data, you make features of interest, so essentially polygons that you look at, you prepare analysis-ready data in some way through pre-processing, and you bring these two together in a database where you have the zonal statistics of the time series of Sentinel data. And you throw this to a machine learning, a random forest pipeline, And you also look at time series analysis to identify cultivation. And in the very end, you have the traffic light system telling you green if the parcel is okay, if it's compliant, red if it's proven to be non-compliant, and yellow if it requires further follow-up because it's uncertain. So how much of this is done online? Well, the very beginning. So the Sentinel-2 data are, of course, hosted online, and the farmer claims are in an online database. And all the rest is done in-house, in the server farm of the paying agency or their subcontractor. What's the reason for this? Well, most of the times people think if we own it, then we can control it, then we know exactly what's going on. So this is how typically a cap monitoring system is set up. And these criteria are reached by building a system in-house and operating it through your own capacity. So you have a high-performance in-house computing center that takes care of your reliability and accuracy as well as it does. Often you store many intermediate products for the sake of traceability. In case of Hungary specifically, actually the imagery is rehosted by the paying agency and shared to the farmers in order to allow them to look at the data, which is quite a big deal of data storage as well. And it's built on open source code modules and an in-house code warehouse. So what's the new approach? With the Copernicus Data Space, essentially the whole thing, every step of this can be hosted online. You have virtual machine processing capacity, which is directly sitting on top of the data archive. So you wouldn't need to build this in your own data warehouse. There's this system of APIs for streamlined access to data. So not only just downloading an image, but already downloading an image product. There's all these code libraries and packages on board that you can build on. There's also a software as a service solution. So for those of you who don't want to build anything, Sen4Cap is, for example, up there, readily available. And the whole thing is built with fast prototyping and scalability in mind. So if a new algorithm comes up, it should be very easy to test it on a small scale and then scale it up all the way to the market. So this is an example of an API-based pipeline. It looks very similar at the first glance. You select the imagery, you do cloud masking, you integrate with parcel outlines, you calculate mean and DVI, you look at cultivation events, you look at the size and homogeneity of your parcels, you detect mowing, and in the end you output red or yellow or green signals for your parcels. The big difference is this is done using API access. So essentially, the whole thing is processed online. You're not really doing any big data processing in-house. And of course, this is going to speed up the process massively. So the same requirements can be reached in a different way. If you want reliability, of course, the first step is that the Copernicus Data Space Ecosystem is governed by this service level agreement. It's going to be there for a long time. You can actually rely on it. It's even more reliable often than building something for yourself. And there are standard ready pipelines in there which can be easily traced. We have the traceability API. We have documented processing tools where every single step can be followed up. You don't have to serve the data directly to your farmers because an infrastructure for showing images is already there. The Copernicus data, the Copernicus browser is available. You only have to provide a link of one line and they can pull up the image and move it around and look at the time series themselves. And since it's so flexible and modular, adding new functionality should be really, really easy in the ecosystem. This visualization service is actually going to be a game changer also for the paying agencies themselves. In many cases, the operators are sitting there and trying to have a look at satellite imagery time series, which they need to pull up in a visualization environment. And this is a really capable visualization environment, including an ecosystem of custom scripts. This one is agricultural growth stage, so it actually looks at a time series of several months to select when the crop was at its maximum. This is inside the browser. It's not a specific processing done afterwards. So we have this ecosystem, and specifically for camp monitoring, we have a lot of code libraries. We saw CropSAR, we saw EOLearn is another Python package that's specifically for Earth observation and monitoring. I already introduced Sen4Cap. So these things are there as building blocks to build a new cap monitoring solution. And then once you have something, with this infrastructure, it should be really easy to share it and move it to new areas. So things like parcel delineation or crop identification have been tested, moved around from one country to the other with the same backend, and that means it's performing really, really well. And so another benefit of satellite cap monitoring was actually spin-off applications for precision agriculture, for protected area monitoring. And these are also made a lot easier now with the data space ecosystem in the cap. So I do think we have a butterfly. I think this is a major transformation opportunity for cap monitoring. Of course, it will contribute to a more value for money cap, but it will also make a lot of new applications possible with a similar transformation approach outside cap monitoring. Thank you, and with that, we have time for questions.
Okay. Thank you very much, Andreas. It was amazingly concise and short introduction to area monitoring system and common agriculture policy. Thanks. You did it in 10 minutes, so we have still some questions. So please raise your hands and we will pass you a mic. So also the people from the online can hear you. Do we have somebody for mics or? Okay.
Yeah, now it's on. I have a question about the future of this system. As we saw, there's going to be new applications, and if I understand correctly, it is an evolving or continuously evolving system. So we should see, excuse me, new applications, new products as well. It's actually a question that I had for Elisabeth because it's concerned with funding. Will there be kind of an R&D initiative that is maybe supported either by ESA and or the Commission to add new products to bring together also scientific institutes along with the industries to jointly develop new products and add continuously to it and thereby create more business, because this is what Copernicus is all about. So will there be an initiative and also funding about this?
Yes, Wolfgang, thank you. Good question. Yeah, there are two elements built into the contract that we have with ESA to support this. One is that we have really a KPI monitoring on this continuous improvement of the data space itself, which means if we manage to constantly add new data sets, add new services, we get a bonus for that, yeah, as you can imagine. So for us, there is a real driver to do this. And I think for the ones that contribute, I think they will have, of course, a win-win in terms that they benefit, yeah, from running it in the data space. And the second element that we have agreed in the contract with ESA is that we also will start, probably end of the year, early next year, we will start with a best practice procurement for particular, say, more research-oriented functions or new processes or new tools where we feel that there is a demand, yeah, to create the best fit for that demand. And that best practice procurement will then be open. Yeah, it will be published on ESA STAR tendering system so that all parties in Europe that want to contribute can apply for. Yeah. And then, of course, we will work closely with the Horizon program, with other activities to see what is also going to be published here or picked up by the user community to, like we have seen with OpenEO, yeah, also started as a Horizon project to add new elements out of those programs. Yeah.
Okay, thank you very much. There was one question there.
Yeah, thank you for this very comprehensive overview of what you're doing. I mean, if this is done well, it should be really valuable to this community. Just a quick question really about, can you say anything about uptake so far? So how many users do you have, and what are your sort of targets or KPIs for users after year 1, year 2, so on? And are you taking steps to migrate users from the other DRCs onto your platform? Thanks.
Okay, yeah, I don't have numbers in mind.
Yeah, it will be one of the things we will very closely monitor, and we will also publish it on a dashboard. Yeah, I think some of you will know that there is already the dashboard function on the Open Access Hub, and we know that there are already more than 700,000 registered users on the Open Access Hub. So this is the starting point. But we also know that out of the 700,000, not everybody is as active as anybody else. So we have, from the very first moment where we started in January, we are now in the range of 20,000 registered users already, even not having all the services, so that's a good sign. We also have already really super users that are really using the data a lot, which we can see in the platform and which we will also publish on the dashboard so that you can see, of course, how much data is being downloaded or maybe how many machines are running in the background. And then, of course, we know that with this data access, we think we can grow into a whole new direction. Yeah? Because today, I think even the 700,000 is still representing the expert community. But what we want is to break the barriers and make it also available and usable by others, yeah, that are maybe not the experts. So I think if we can go from 700,000 to 7 million after 6 years, I would be happy. Yeah? That is the dimension that we are talking.
Okay, thank you very much. I think there are some questions also from online, so maybe I will address them quickly. So the first one, why only offering selected products from the Copernicus services? If I need a data set from a Copernicus, could I ask it to be added? As I said, we are not aiming to duplicate what is already available within the Copernicus services. We just want to make our ecosystem more attractive. So if you think that there is a data set that should appear there, you can always post a request on the help desk and we will evaluate it. And the second question is how is Copernicus data ecosystem different from DIAS's platform available? Does it plan to replace the DIAS? So the answer is no, it is not going to replace DIAS. DIAS is a commercial part of the ecosystem. Within the ecosystem you have some credits, you have some quotas for free, but in case you would like to do a large scale processing, then you have to pay for it using the one of two clouds. So there is the Cloudflare's cloud and there is the OTC cloud. Okay, now I will give it mic to Mark for a question.
Thank you, and thanks to all for these interesting presentations. My question is on kind of the user interface and specifically user support. I mean, if we want to think in the future of how we transition both some of the core service elements onto this infrastructure, but also how downstream service providers would actually operate services from this infrastructure. How do we ensure that user support, which is a core part of Copernicus in service delivery and things like this, is maintained for services that are provided through the CDSE? I mean, of course, you have your own help desk and things like that, but the service providers themselves who have the thematic and technical knowledge on this want to be able to do that as well. So how do we ensure that kind of user interface and user support aspect? Thanks.
Yeah, this is a very good question. I don't know if we have thought about this. Yeah, so maybe Dennis?
Yeah, I can briefly answer that. So currently we indeed operate a help desk, and because there are so many components in the ecosystem already, we interface, let's say we federate as well with all our partners in the ecosystem. So that means that we have a direct integration with their ticketing systems for the users. So I think basically for the Copernicus services or other people that would be onboarded, we can do it in the same approach and have some kind of a federated approach there. So we have only one access point for users to ask their questions. I think that would be the best approach. I think we always have to look at it from perspective from the user.
Thanks. So if we can have one more question from online about the, it's changed. There was a question about the data from farmers that are ingested in the system and about the IP rights. So maybe Andras, you can answer this.
Yes, I think I can. So data rights, I think, are really carefully handled inside Copernicus Data Space because it is designed to be a good federated platform between the commercial and the public sector. And the farmers' data is handled by the paying agency in the framework of the payment request. Now, if you create a statistical API request to get zonal statistics of a particular parcel and you pull them down through the API, you're not actually creating a data record of that polygon of interest inside the browser or inside the data space. It actually involves a lot less movement of personal data or vector-based third-party data than the previous approach where you are sending it to probably a subcontractor who's processing the data. I hope that answers the question.
Thank you very much. I think we have to wrap up because there is a message on the screen. So basically, once again, thanks all of you for joining us today. And if you have some other questions, we will be available during the lunch break here at the desk in the coffee rooms, and then they can please ask if you have some other questions. Thank you very much to all speakers, and have a nice lunch. Thank you.